Okie dokie. Sounds like a plan. Let's get into slide mode. That's that one. Slides. Cool. All right. Hello. So my name's Sam Mullen, as you might have heard in the preamble, and I work for a company called Advancing Analytics, and we do lots of consulting around building lakes and doing data science and doing data engineering and all of that stuff. Now, one of the big things that we do is I spend a lot of time building Spark engines and building various bits of data processing and doing data engineering using Spark. And with the advent of Synapse coming along, there's that big question of going, well, isn't there already ways of doing Spark in Azure with HD Insight first, and then with Databricks, and now we've got Synapse? And so that kind of big question is kind of what this came around to answer, is to say kind of, which one should I use? How does that actually fit together? Now, we're not going to go too heavily into the competition side of things. It's more to give you guys just a bit of context about which one does better than the other, how they both work, the different approaches they take, especially when we're talking about clusters and sizing and all that kind of stuff. And as I mentioned, I do want to dive into a quick demo just to say this is the Spark that changed how I work. So kind of just this is why Spark makes a difference, and why, if you're going a pure Synapse route, why it's really important to have a bit of Spark in there and the kind of use cases that would fit for. So that's the plan. They are the things I'll be going through. So yeah, let's have a bit of a look at Spark itself. So this is the classic, the way we've been building warehouses for an absolute age. It's the get a load of data, put it into a staging table inside some kind of relational database, and then pick it up and do some row filtering out, kick out the bad data, apply some cleansing, scrubbing rules, and put it down again. Pick it back up again, and then shape it into my facts and dimensions and various other kind of analytics constructs. That's kind of like the normal happy path that we go along. Now that has problems, it has issues, especially when we're dealing with relational databases, especially when we're trying to do things quickly. So these days, when people are saying, I've got a new data set, we need to really quickly analyze it and start working with it and then actually make some decisions on it, then it's kind of too slow in the traditional world. Now we've seen a load of these SQL serverless, and that's great for doing that kind of early looking at some stuff. I've got some files. Can you look at it? Can you tell me what's in there? Yeah, you can now write a query in SQL directly over that stuff. But saying, can I land it and shape it and actually start preparing that data when I've never seen it and I know nothing about it and I don't want to have to release any code, this starts to fall down. So what we tend to see now is people actually going, you know what, I'm going to bring in a bit more of a mix. I'm going to actually start doing a little bit of pre-preparation. I'm going to do some work inside a lake kind of area to bring stuff together, to prepare my data, and then I might still put it into a relational database. So in some ways, kind of like the staging area becomes actually much more fluid and much more adaptable. And then as things grow and as things mature and as the kind of the lake technologies have matured, we just start doing more and more and more in that lake side because it's so flexible and so scalable. So that's kind of the history of where it's coming from. It's not kind of essentially just going, you can ignore all things to do with data warehousing. It's making the earlier parts of warehousing much faster and more flexible, and then slowly taking over some of those other parts as it matures, which is all pretty good. Okay, so what's inside Spark? So Spark itself is a Java-based engine. So it sits inside a JVM currently. There's issues on that, which will come to you later. And essentially kind of loads and loads of things called Scala, which compiles down to Java and is quite low-level code. And that's fairly tricky to work with. It's got like a lot of complexity sitting in there. And one of the whole kind of mechanisms behind Spark is this thing called an RDD, a resilient distributed data set. You don't have to worry too much about it. Essentially, if I'm reading data from down in a lake or something like that, I pull it into memory, chunk it into a load of different blocks, and then I can scale by saying, well, actually, each machine needs to have 10 blocks of data. Oh no, I've got more machines. Cool, each machine only needs to have 2 blocks of data. Each machine does less work, therefore I can scale out really nicely. And this whole way of managing data, managing one of my machines blows up, it's fine because I can just repeat that piece of work and not have to start from the beginning. It's built to be scalable and resilient and very, very cloud friendly. But even so, when you're working on that, it's fairly tricky. RDDs, you have to write recursors and say this is how to iterate through it, this is how to add up. And so if you're coming from a traditional warehousing background, you just want to be able to write some SQL to work on the data directly, and that's just not good enough. In that way, the RDD side was like the entry level. That was a very immature tech. But then since then, on top of all that stuff, we now have two APIs. There's the data frame API, which we can use via Python, via Scala, via R, or via .NET, depending on environments, which we'll come to, or the SQL API. So you can just write SQL, and it'll turn it into RDDs, and it'll turn it into Java, and all those abstraction layers, and all that kind of stuff in the bottom. But actually, you don't have to worry about that. You can just write a bit of SQL at the top, and then it uses all this maturity of the big data engine, all of this big scalable, cool stuff under the hood. So essentially, Spark is this beast of an engine that you can just go in a really friendly, nice entry point at the top, and everything becomes a lot easier. You know, we talk about scalability. So this kind of thing, when I've got a load of data sitting in a lake. So at the bottom, I've got ADLS with some CSVs. So I've got like my data chunked up, you know, because Luke was saying in terms of partitioning that data, I've got loads of different files, or even one file that has different chunks I can read in serial, in parallel, has been serialized out across my lake. So when I actually query it, when I write a bit of Python, throw a bit of code to this top thing, I've got a driver, basically a brain that's kind of interpreting my queries and deciding what to do, passes it down to my various different workers. And that can be one worker through to several thousand workers. That's the scalable part. So you have one worker and then just a number, so one driver and then a number of workers that goes up and down. Each worker will do its own bit of work, complete in isolation, bring the data back up into memory, it'll do some work, maybe pass all its aggregates onto another worker, do that as a second stage, pass some data back, and then I'm done. So you get that kind of very chunking up, breaking data up, bringing things together, passing up. It's kind of very, very built around parallelism. The whole point, it's a big parallel engine. And yes, no, we're not talking about other things that happen. Okay, so today we're talking about Synapse versus Databricks, or kind of just doing that comparison of them. So if you're starting out and you're going, I want to do some Spark, where do you do it? So Databricks is kind of like it's weird because Databricks still feels new, but it's kind of the old incumbent place to do Spark in Azure these days. So it's actually really back in 2016 in AWS. So it started off in Amazon. You can use it in Amazon or Azure these days. So it is kind of cross-platform. So if you build out a package, a solution in Databricks, it is nicely compatible between the two. And it is using their proprietary runtime. So that bit of history, the guys who invented Spark, you know, kind of 10 years ago, they invented this thing, they made it open source. They then started the company Databricks to keep developing and managing this open source platform. So Matej Zaharie, Ali Godzi, Reynolds Zinn, Michael Umbros, the guys behind the actual original Spark, work for Databricks and run Databricks. So you see a lot of the performance optimizations and a lot of the momentum, a lot of the movement to push it ahead is actually coming from Databricks because it's the same guys who invented the thing in the first place. That's their key driver. So what Databricks is? Databricks is a third party. It's not a Microsoft product, but it is a first-class citizen in Azure. So you can go in, log it, platform and service, all of that kind of stuff. So Synapse Sparkles, on the other hand, so that is going back and using the open source Spark engine and then building and starting to build Microsoft's own runtime. So it's separate from the Databricks runtime. It's only available in Azure, obviously, because Synapse is very much an Azure thing. And one of the big things, we'll come on to the Synapse runtime. But so currently the open source standard for Spark is Spark 3.0. And that has a whole slew of cool features in there for doing things like, I want to join from a fact table to a dimension table, filter dimension, and have it cross-filter my fact. Kind of obvious, right? Spark, again, it's been maturing. It's only really got the optimizations to look after that kind of thing. It's not in Spark 2.4. So the current Synapse version of Spark is a little bit behind. But we're expecting that to accelerate. You know, it did only went GA a few months ago. So we're kind of going to expecting to see a little bit of acceleration about how they start baking in some of those optimizations. But we'll kind of see. But then on the other side, Synapse has a lot of benefits from the things it can talk to. I mean, the rest of the things we're seeing today, all of this Synapse ecosystem, talking to SQL serverless, talking to dedicated SQL pools, being able to talk to Synapse Link and get the HTAP things directly from their Spark engine, that's going to be nice kind of benefits on the Synapse side. So you're kind of getting that differential of kind of pure Spark. Databricks is edging ahead with the optimizations and the engine. But then all the other ecosystem parts, Synapse is still immature, but actually has a load of potential there. Okay, so Databricks, we're not going to go too much into, but Databricks is more than just an engine. It's a whole workspace you can log into to do. It's got its own user management ecosystem, a security, you can see different things. You can write notebooks, we'll have a look at those. It has its own scheduling system, so you can set up jobs and have them triggered and run them on a certain orchestration schedule. You can upload libraries and manage all your code and have has some decent stuff in terms of managing dependencies and code stuff. It has its own storage engine, and you can spin multiple clusters in there. Again, this is no Databricks talk, I'm not going to go too deep into that stuff, but just be aware that it is actually a portal and a workspace of its own. But all of it, everything in there, is focused around that cluster, or that bunch of clusters you can use for different things. So they're all tools and utilities to allow you to use that Spark engine. Now, when we look at Synapse, on the other hand, I mean, as you've been seeing today, there's this whole range of different tools. It's not just about that Spark engine. That Spark engine is just one piece of the wider Synapse puzzle. And again, that can be pretty hard when you're first starting out with Synapse. It's like, what is Synapse? Synapse is this whole bunch of the MPP dedicated SQL pools. It's the serverless Polaris-based engine doing Lightning queries, and it's a Spark engine with orchestration and management and all of that stuff in there. So the Spark pool is just one piece of that puzzle, which is maybe why it doesn't have as much focus as the entire organization of Databricks, which is just building that one thing, that one cluster inside their workspace. So a bit of context, they are kind of a piece versus a big thing, and there's different things that they're aiming to do and different things that they're trying to deliver. So, well, that's getting started with, that's meant to say Spark. Let's switch over and have a bit of a look at the actual Spark engine. So you've been seeing Synapse, and you actually got a bit of a dive into Spark when Terry was showing machine learning earlier, if you made that session. There's a load of stuff in there. So I just want to show a real quick, high-level example of why Spark made a massive difference to how we work, especially to me as a data engineer, someone who just wants to get data into the system, run a load of jobs to clean it up and shape it and get it in the right state, and then kind of pass on to do analytics on top of it. I use Spark heavily for that. Okay, so we're over in here. We can see everything that's okay. So first and foremost, we've got inside our management, we've got these things. We've got Spark pools. We've currently got 2 different Spark pools set up. And we'll talk a little bit more about how that compares to clusters versus the breakdown of kind of Spark pools. But essentially in Synapse, what we're saying is, what's the total size of VMs I want to configure? So if I do a new one, give me some options, my pool name. So I want to choose what the node size is. So I'm going to have a number of VMs. There's essentially a bank of different servers which I'm going to use. How big do I want each individual server to be? Let's call this DT. So I could choose how big should it be? Do I want lots of really small servers? And then each time I scale, I'm scaling up a smaller increment, which I'm doing more granular scaling. Or actually, am I going to have scenarios where, because of the kind of queries I'm writing, I'm dealing with big chunky data sets and I'm having to do sorts inside a data set and I can't spread that out across workspaces. I'm having to do real specific things in machine learning, which means I have to collect data together. So I can't get away with having lots of little small machines. I actually need some slightly chunkier machines, but I can have few of them. And that's a real hard choice when you start with Spark, is do I go for 2 quite big machines, or do I go for 10 really small machines? And getting that balance, it's the horrible consultant answer of, it depends. It depends on the shape of your data and depends on what kind of transformations you're trying to do on it using Spark. Generally, I go really small, make it auto scale so you can have a varying number of it, and then only kind of just switch up when you start to reach those limits. Start off small, grow as you need to. You don't have to commit to the size that you make. That's the nice thing. Okay, so you choose size of cores, whether you want it to scale up and down with demand, and the number of those cores, the number of those nodes that should be turned on. And the important thing is that's potential. That is how many servers I could use. Whereas if I go back to my workspace, I go and have a look at my particular thing, I can say, so I want to attach it to my given pool, but then I have this thing at the top is my given session. So of my available 20 servers, I want this notebook, me in this one session, this kind of me as an individual working with the notebook, to take up a session that is 2 of my executors. I want to use all of my available executors. So you kind of have that difference of how big is your potential pool versus how big is each user, what slice of that pool is each user using. Very, very different to how Databricks does things, and we'll talk about that in a sec. Okay, but inside my notebook, I've got this notebook of code. I've got this thing at the top, this nice, pretty visual. I mean, that's just Markdown. So that's the joy of notebooks, is that you can have this mix of, I'm going to want to have some code, I want to have some Markdown, I'll have some code, Markdown, and you can build some quite, kind of visually descriptive, easy to follow scripts. So you can comment your script nicely, which is always lovely. Okay, so I'm in Python here. I've got a choice of different languages. I can use Python, Scala, C# and SQL. Now, you may notice earlier, I said Spark can run on Python, Scala, R, and SQL and C#. And so Databricks, you can use R. Synapse, you can use C#. You cannot use R currently in Synapse, and you cannot use C# currently in Databricks. So the language choice is slightly different. And here you can see, so because I've chosen Python, everything's in Python here, but I can do things like this and go, oh, actually, I want one bit that's in Scala, or I want one bit that's in SQL. And I can have just different cells, which are different codes, different languages, which means you can be very, very flexible and also very dangerous. It's a heady mix. Right, but on to the whole point. So I've got a lake here. So if I just switch over to my lake, go and have a look what's inside my lake. And I've got a whole lot of folders, a whole lot of management structures, because, lakes have a good architectural structure. I'm going to go into that. And we can go into AdventureWorks, and we can see I've got a whole lot of folders in here. So I have a file path that leads me to a particular bit of data. I've got some partitioning in here. And inside there, I'm going to have just a blank CSV I want to read. So eventually, this whole folder structure, I've got some files that I can then get to and have a play with. Okay, so I want to be able to query that. So I've just made a quick text string. So I want a text variable, which is, this is my location. This is the place in the lake I want to go to and query it. So I can do really quick things and go, I want to use the Spark data reader. And I want to go .read because I'm going to read some data. And I could really just do a real basic one and say .csv. And I pass that location in. Super basic, super simple. The most simple thing you can do is just go read some data. Just go and read the data, bring it back. And then when that's ran, I can do display and say, I want to see what's inside that data. And eventually that'll run nice and quick. They are today. And now that real basic is the equivalent of that, kind of select star from open row set in serverless SQL. Your select star from a table. That is your most basic thing. And the fact that that kind of location is a parameter. So actually this whole thing is dynamic based on what location I put in. Suddenly starts to open up loads of potential, loads of opportunities. Don't know why that's taking so long now, but fine, we'll carry on. We'll come back to it later. So that switch of, I've got a data frame, I can then do things to that data frame. So I could say, add a column to it, filter it, join it to another data set. I can start to add commands up. So we can do things like this. I can say, I want a whole list of tables. I want to make an array that is just a list of all the different things. And actually, in this case, I've hard-coded it. This is just a variable hard-coded in my notebook. But I could actually get that from a SQL database, from some JSON, by reading what's in the lake. So I can have an array dynamically built up and then do things like, for T in tables. So I can iterate through that because it's just Python, print T. So I can say what's in my particular data set. So you can do just high-level generic Python and go iterate through this. Do this for each one of these things in that list. And then when you start putting that together, we can do this kind of thing. So I've put a little bit of an example together. There we go. Way too close. Okay. So we can do things to say, well, for each of my tables, I want to build up a string which describes that path, that place in my lake. And in this case, I'm using a thing called an f string, which allows me to format the string, saying, I want you to actually, instead of this placeholder inside inside that string, I want you to place it with the current table. So it's going to loop through that list. And for each table, it's going to run this whole script, injecting my table name into it. And then I can inject that directly into my data frame. The whole point being, I can write a super, super generic bit of transformation. I can write one script which says, do some data quality, do a bit of data cleansing, replace any columns named this with this value. And then I can just say, run it for everything. And that suddenly becomes a big, big thing when we say, what happens if we get a new table? What happens if we get a new data set into our environment? And rather than saying, I've got to write a new package, I need to go into my code generator, generate a new package, and then deploy that package and test it and do all that kind of stuff. It's just metadata. So I don't do anything. I change the metadata, and then the next time I run this, it includes the new table. And the agility and the kind of the working patterns that are based in that just become insane. That, for me, is the real point of Spark, being able to write dynamic, reusable code that scales so well. Okay, right, time. Don't have that much more time. I need to get back to slides. Did we actually run the thing above? No, it's still running. Okay, cool. Let's just ignore that and carry on. All right. So that's kind of just a little flavor of why Spark is super, super cool. Let's get back to the point. Let's get back to looking at how this differs from Databricks to Spark, from Synapse, because they're both Spark. They can both do that example. Okay, so we talked a little bit about the idea they've both got their own workspace, and they've both got kind of the idea of Spark and as a runtime. So why does it matter? Why does it matter which one you pick? And certainly in Databricks currently, it is quite far ahead in terms of the maturity of that Spark model. The runtime has optimizations. It's got extra features. It's got extra stuff that sit on top of the core vanilla Spark engine. And essentially, Databricks is the guys who are currently writing a huge amount of the open sourced Spark engine. They go, right, we're going to open source all that, and we're going to keep that bit back as our premium offering. So anytime they're kind of pushing loads and loads of code in, they do tend to keep some of the nicer features kind of back to, be able to push their own stuff. Now, the Synapse runtime is actually maturing and starting to add in their own optimizations and their own functions and their own extra things you can do on top of it. But just as it currently stands, it is a little bit behind where that Databricks runtime is. So talking about it in terms of that kind of playing catch up, Databricks already has Spark 3.0 and a load of optimizations on top of 3.0. And again, that's that thing that has things like adaptive query execution, which just changes the query plan to be better optimized as soon as it sees it to perform still fairly static. It has lots of that kind of advanced deep engine kind of things. Now, at some point, we're going to see Synapse get Spark 3.0, surely, but not yet. We're hoping it'd be there for GA, but it's not yet. I have no idea what the roadmap is, so do not ask me. But then already we've got the preview of the thing called the Photon Engine in Databricks. So Databricks have already released and kind of firmed up and hardened this thing called Spark 3, and then now we're doing this next thing. So whereas earlier I was talking about Databricks being based on, Spark being based on JVMs and Java and all that kind of stuff, they've rewritten the entire Spark engine to run on C++ to get rid of Java kind of VM utilization. So they've kind of got the next gen, almost like sort of Spark 4.0, but not an engine, more how it works. So when eventually we see Synapse catching up and doing Spark 3.0, Databricks might even be on the next thing. So there is a catch-up game currently happening that the Synapse Spark pools are behind on. In terms of, we talked a little bit about kind of how that cluster looks and how things fit together. So we talked about having a Java virtual machine, this JVM. Then inside there, we have like a thing called executors, we have slots. There's a whole component architecture as to how it takes work and then just passes it across this different architecture. Essentially, a slot is a CPU. So I've got a chunk of data, I've got a CPU. One CPU can process one chunk of data at a time. That's kind of how that works. So the more workers I have and the more CPUs each worker has, the more work I can do in parallel. Kind of scales out. And that's how Databricks works. So Databricks is a traditional cluster-based Spark engine when I span out a cluster, and then I can give it just a load of different work. I can say, run these 10 different jobs. And across the available workers, across those slots, it'll go, okay, well, you're going to use 4. You're going to use 4. That means I've got 4 spare, so I can fit that one in there. And it manages work across the cluster. Now, Synapse doesn't do that currently. So Synapse, we have that Spark pool. That's the thing we mentioned of the number of potential servers we could spin up. And then when I open a notebook and I start a session, I jump on one of that. And I have those workers to myself. I'm the only person using that session. So someone else comes up and opens a notebook and says, I would like to also do some work. They jump on a different VM allocation in that Spark pool. So if someone runs a query and is using all of their particular session, and then someone else is not actually, they're running a much smaller query and they're not using that much, it's not going to spill over and use and kind of just dynamically allocate. It's you're using your session and that's as much power as you have. And there's pros and cons with that. So with Databricks, I can be a lot more highly concurrent. I can throw lots of different work at it and it'll figure it out. With Synapse Spark Pools, there is zero ability to, there's no data leakage. So if you're doing a very, very highly secure, absolutely, these two people, there's no way down in the logs they could see what each other's doing. We can do that kind of thing if we're in the Synapse Pools. And so it kind of depends on the kind of thing that you're after. But essentially, Databricks will be a little bit more flexible, a little bit more dynamic. Synapse Pools is a lot more fixed. If you are working on your cluster, this is what you're currently doing. Okay. So some special things that they can do. So Databricks, we've got things like DB utils. We have library management. It can do secrets and talk to Key Vault. They've got all these kind of functions and things built into it, which is quite nice. It has display and charting. But again, Synapse Pools have an element of that. You can do charts. Databricks has a more sophisticated like dashboarding engine built in. But then Synapse can also just plug into Power BI. And depends on if you consider that part of the workspace or it's putting onto a different tool, kind of up to you. And yeah, kind of generally some of the version control things. We've now got version control in Synapse. When I originally put this together, we didn't even have that. So the fact that we can now do elements of CI/CD, we can check in on notebooks, we can do that kind of thing, makes it a lot more dynamic and a lot more nice to work in Synapse Pools. A little bit more natural in some of the Databricks things, but then their Git integration isn't perfect. For Synapse, the benefit are we've got a lake browser built in, which it's still not really in Databricks. So the fact that we've got this one workspace where we can go and have a look at the data, pull it back, right click and open it in the notebook, that kind of ability to explore stuff is a lot richer, is a lot nicer. We've seen today, we've got kind of Data Factory built into it. All the orchestration and how things are actually sort of fitting together is all actually working quite nicely. Cosmos DB. So, again, we saw, as I think the second session today was all about HTAP. It's all about how things actually fit nicely together so we can be working with Cosmos DB and then immediately query that data in real time or near real time without having to build complex ETL integrations. Again, Synapse Spark Pools, they really benefit from integration. One of the questions I just saw is, does Synapse Spark support Delta Lake? It does. It supports the open source version of Delta Lake. So again, that's one of those kind of comparisons of Databricks has got Databricks Delta, which is Delta Lake, the open source one, and a load of extra premium features on top of it. Things like the optimize command are Databricks Delta only. Whereas if you're trying to just create a Delta table, you can use that in Synapse Spark or you can use that in Databricks. So it's kind of quite easy to work backwards and forwards and all that kind of stuff. Okay, metadata. How are we doing for time? Oh, we're okay. Blasting through it. It's all good. So both ideas have this thing called Hive built in. So if you're working in Spark, you're generally working in flat files, right? You've got a lake, you've got directories. You're creating lots and lots of Parquet in there. But that's not necessarily nice to be able to read. It's not necessarily natural to be able to go to a business user, hey, just go and query that folder. And they have to write that data frame and write something to open it and read it. So on both sides, you can do all that Sparky bit. I can write a load of Python, and then I can go save it as a table. Just make it look like a SQL table so that anyone actually interacting with it just gets a list of databases and tables. Now, underneath that table is actually folders and folder structures and metadata and Parquet files and CSV files and whatever it happens to be. So Hive is this great like abstraction layer on top of it so you can go and query it. Now, the benefit on the Synapse side is that Hive layer is also actually accessible by serverless SQL. So I can do all that stuff I was doing in my notebook. I can write a load of Python to loop through a load of stuff, create those things as tables, make it as dynamic as I like. And then when I've saved it as a table, I can switch over to Synapse serverless SQL and be able to query those same tables. So the communication between the Spark side and the serverless SQL side is really, really nice in Synapse. One limitation is that that doesn't work for Delta tables currently. So if I save my data as Parquet and expose that as Hive, that'll be immediately queryable by serverless SQL. Doesn't work for Delta. But, eventually, I'm sure we'll see that happen. The plan. Okay, the other side, you've got Spark.net. So in Synapse, we can use C#. So if you are a Microsoft house and you have loads and loads and loads of .NET developers everywhere, actually, they can just write .NET directly to integrate with this Spark engine, which is really, really nice. And it kind of opens up essentially this whole big data ecosystem to a whole slew of different developers. Now, Python, Scala, when you're learning this for Spark, actually, there's not too much difference between how the languages are implemented. The majority of things you're doing is learning how the Spark API and the Spark commands work, and then just implementing it using the syntax of whatever language you're using. So actually, the C# syntax of interacting with data frames and adding columns, removing columns, joining things together, it looks very similar. You might have a difference in terms of when you capitalize on what kind of quotes you use. And obviously, lots of semicolons. I did a video about it when I just constantly forgot semicolons because it's been a while since I've written .NET. But that's it. It's language syntax. But actually, the commands stay the same across language, which makes it very easy for you to, someone's written something in .NET, you can open it as a Spark dev and go, yeah, okay, I understand what's going on in there. That's fine. The reason why they chose not to have R inside Synapse is fairly surprising because the vanilla Spark engine does support it. And it kind of like alienates a lot of people in data science. Data science, you get the two camps of Python developers, R developers, a lot of R developers coming from academia, but that's not available in Synapse. So be aware, if you're currently using Spark on-prem, open source, Databricks, and you're looking to migrate it over to Synapse, be very aware, it does not currently support R. Okay, we mentioned the Delta engine. So that's one thing that is purely on the Databricks side. So this switch to get away from relying on the JVMs to massively improve the interop. So if you're bringing in a library in Python that's not a Spark library, so you've got like traditional Python, you're just going off, you're looking at pip install, you're bringing in a library. Now every library will know how all that workers and scale works. So if you bring in a PySpark, that is Python for Spark library, it's generally built to know how to scale, to be able to spread work across all the workers and get parallelism. Bring in any old other Python library, or you create a Python function yourself, it might not know how to scale. And so you won't really get that kind of thing. It'll have to, basically each worker will have to send data outside of the Java virtual machine, talk to Python, which doesn't run inside Java, get the result back. So because they're switching over to the Delta engine for Photon over in Databricks, that doesn't need to do it because it's not running in a Java engine, it's using C++. So suddenly its ability to talk to other languages and talk to other things gets a hell of a lot quicker. And there's a lot of other stuff they're doing inside there as well. But just that currently is a Databricks only advance. Now on the flip side, you've got another thing which is on the Synapse side. So Synapse have built something called Hyperspace. I keep calling it hyperscale. And that is an indexing subsystem inside Spark. So Spark doesn't have an index, it's flat files, right? You just have, here's all my data. And Microsoft have implemented something called Hyperspace, which allows you to scan all the data and then separately keep an indexed version of that data, kind of like a covering index with some of the data in there. So if you go and query it, you go and query your table, it goes, oh, actually we've got an index for that. Query that thing, it's going to be much faster. And it has some things to keep it up to date, keep it maintained, do all that kind of stuff. Whilst Databricks does have the ability to add a Bloom index, which is a similar idea, it doesn't have quite the same concepts. And so we're starting to see that. We're starting to see slight divergence. So Databricks putting some stuff in and some stuff in. Synapse starting to build out some things on the Microsoft side as well. So whilst it currently is that state of Databricks has the optimizations, it has the extra stuff, Synapse has the integrations and is starting to see additional development, additional things creep in to move it forwards. Okay, talking about Delta and the open source stuff. So Databricks actually put out these two things. So MLflow is a machine learning experimentation tracker. The whole way of when you're building an ML model, you can say, well, I ran it with these parameters and it did that well. I ran it with these different parameters and it did that well. Here's all my different experiments. That one's the best one. I want to take that model and push it live. That whole kind of process, kind of similar to what Azure ML does. And MLflow is this process being developed by Databricks and open source. And that's baked into Databricks. Whereas on the Synapse side, obviously, it can talk to Azure ML. So you've got like your choice depending on what your flavor is. Obviously, Azure ML does now support MLflow commands. So the line's blurring there a little bit. As we said, Databricks has Delta, but it has Databricks Delta, this premium version of the Delta file format, which is based on Parquet, but gives things like ACID transactions. You can roll back, you can do temporal queries, you can write a merge statement, all these traditional things that if you're coming from a database land, you go, yeah, that's normal, right? Not been normal in lakes for a long, long time. So the fact that we can now have some of the maturity that we have in a relational engine, but we can do it on top of a lake is awesome. And the Databricks version is the premium version. We've got Databricks Delta. Synapse use the open sourced version, which lacks a few features with one or two things you have to do manually, but still cross-compatible. So you can use Databricks, do a load of processing, land them as Delta tables, and then open those Delta tables inside Synapse. So because that is a cross-standard open format, loads of really good integration options there as well. So it's not always I want to use that one, not that one. Okay, a little bit about price. We're doing okay for time, should be good. So generally, Synapse, I think I got these prices, in the preview. Might not have updated this. Generally, Databricks is a little bit more expensive. You have the Databricks license that you're paying, a little DBU cost that you pay on top of each of the VMs. But currently, Databricks kind of scales a little better, and you can set up a cluster and reuse it more. So if I can have one cluster and use it for 10 different things and satisfy my 10 different users from that one cluster, then that's going to cost me a certain amount. If the same 10 users are trying to use Synapse Spark pools currently, they will each have to have 10 different sessions, which will have its own, essentially, mini cluster spun up, its own worker allocation against it. And it's kind of interesting trying to say, are you just doing one thing? Are you doing one job? In which case, Spark pools might be cheaper. Are you trying to do lots of jobs at once, lots of things in parallel, or managing several concurrent users? In which case, currently the patterns look like Databricks is going to be the cheaper option, despite being the more premium offering. But again, consultant answer, it depends on your workload, your number of users, what you're trying to do with it. But always get that idea of you're having an amount of compute per user, and in both sides, they have an auto terminate. So we can say, actually, I want to start working it. As soon as I start working, it'll spin up a cluster. So I've got to wait for that cluster to turn on both sides. I can say, if I've not then put in anything for 10 minutes, turn it off automatically. If I've not touched you for 20 minutes, turn it off automatically. You can start to play around with that kind of thing to, have things auto turn off. And on both sides, that is an awesome feature because I used to spend my life writing PowerShell scripts to, has the job finished? Has the job finished? Has the job finished? Yes. Okay, I can now shut down my servers. And the fact that we no longer have to do any of that kind of stuff is so nice. And yes, I am using pounds. Come on, it's fine. One thing on the Databricks side is we've got this thing called autoscale. So autoscale is looking at this whole cluster. So I've got my driver and I've got a number of workers, and it's just changing the number of workers that I need. So both sides have this. So Synapse has a version of autoscale, which is just add more workers to my pool. But when I'm on Databricks, the autoscale that is available in the premium version of Databricks is a lot more smart about how it works. So if I put in a huge job and it can see that, well, it needs 10 slots, 10 bits of CPU at the start, and then it's going to need 200. Then it's going to need 200 again, and it's going to go down to another 5. It'll actually look a little bit ahead of that and go, I'm going to need some more workers in a second. I'm going to need to do some more stuff. But when it's actually scaling down, it scales very, very sharply. So if you're using Databricks in standard mode, it's more like every 10 minutes I'll check out, I can turn off one server. I can turn off one, and it just really, really slowly scales. In premium mode, premium autoscale is very, very good at going, I can turn off all of these, I'm done with that. I'm going to need more soon. I can turn them all off. So the elasticity of your compute is very, very good if you're using Databricks autoscale in premium mode. Again, love it. It's very, very good for cost management, cost saving. Obviously, anytime you're dealing with autoscale, occasionally you'll submit a query and it'll have to wait a minute or two because it's scaling up, because someone's already using some of the allocations, and the extra allocations you need have to be provisioned. Autoscale does mean there's a little bit less predictability in terms of how long things take, because sometimes it's scaling, sometimes it's not. But generally it means things are cheaper, and generally it means things are faster because you can have it running on a really low size and then just spike up when you need it. The whole point of the cloud is elastic scale of compute. We don't know what Synapse is going to look like in the future for that. Generally, the Synapse Spark Pool story is currently for engineering works, for predictable workload. I'm going to be running this set of jobs, this set of notebooks, kicked off by the in-house, the Synapse pipelines, and it's a lot more manageable, a lot more steady. It's kind of expecting a lot less spikes of sudden lots of people coming in and working it. So you may have kind of gotten the message that I was pushing across that. Databricks is a better Spark engine currently. I know I have to apologize, but it is. But that's because it is a premium offering. So if you're paying just for a set cluster that's just turned on and not scaling, it is a more expensive option. It does do more stuff. You're paying for the premium brand, and And that's because the Spark SQL pool is fairly new, a little bit immature, and it's going to eventually speed up and get more features. But as it currently stands, Databricks is the more premium offering. But that's not really the end of the story. It's no longer a preview, ignore that. And that's kind of the message I was trying to put. Of kind of like, it's kind of like looking at Enterprise SQL Server to standard. Databricks just has some features, some optimizations, some extra things in there, which are better, but they cost more. Synapse Spark doesn't have some of those additional extra features, doesn't have some of the whistles and bells, but it has other features and has other integrations, which are really, really nice and easy. And there's less configuration and setup. There's less thought you have to do when you switch on a Spark pool. So it comes down to, what are you trying to achieve? What is the point of you using Spark in your given solution? If you're doing lots of warehousing and you have dedicated SQL pools, and you're doing a bit of serverless SQL pools, and you're doing orchestration inside Synapse, everything is inside Synapse. And there's like one or two things that come up going, oh, apparently we need the Spark thing. We should like sort of bolt on a little bit of Spark Engine into it. It's a no-brainer to kind of use Synapse Spark pools built into that ecosystem. It's something you can just switch on inside that same thing and not worry about integration, not worry about how they connect, not worry about how you're authenticating across stuff. It's very, very easy to get started and get working. Whereas if you're actually going the whole lakehouse kind of way, I'm trying to actually build up a very complex Spark application. I want to build a framework that I throw any data set and automatically gets processed and kicked out the other side. You're probably going to have a better time in Databricks because it is a more advanced, more feature-rich Spark implementation. So it's the classic, it depends on your scenario, which of those sides is going to be more appropriate. You know, I think the tagline that's currently pushed by both sides marketing is better together. And actually, we see a lot of architectures. One of the default standard architectures that we build is this combination, this saying, all my upfront stuff, all my agility, all my unknowns, my sudden spikes of data coming in that I don't necessarily know how I'm going to deal with it. The people sending us audio files, video files, all the kind of the complex objects that I can't just squeeze inside a dedicated SQL pool. I need to land it in a lake and then interpret it, figure out what I'm going to do with it, encode it as numerics if I need to then put it into a ML model, all that kind of stuff. We tend to do upfront in the lake where it's fairly cheaper and we can throw elastic scale at it very, very easily. And then when the data is a little bit more matured and curated and shaped into more traditional analytics models, then we can expose it into maybe serverless SQL pools. If it's big chunky data and it fits that nice big old fact, some smaller broadcast dimensions, put it into dedicated SQL pools. But we've got those options that actually, it's a scenario that each thing fits together nicely. Yes, the main point is Spark is awesome, right? So if you're trying to do data engineering, I mean, so certainly in terms of how we work, we have built load patterns. So if we are loading data, we've got these things called raw, base, enriched, stage, clean, warehouse, whatever you're calling your various different layers of your data curation process. We get data landed in its raw format. And if that data is in a completely different shape, if the vendor's thrown in extra columns and done all sorts of stuff, we can still land it in the lake. There's no table structure we're forcing it into. We can land it, and then if we have to query it and work out if structure's changed, we can do that within the lake. Spark's quite good and is getting better at detecting things like schema drift. So Delta tables, we can have merge on there. We can say, you know what, we don't even need to change anything, just automatically add those new columns in. And that suddenly becomes super flexible and super kind of extensible. So we have this whole scalable early site area, which is our lake, which is using Spark, which if you're not doing any of that kind of stuff and you're currently writing SSIS packages, and if someone comes along with a new bit of data or the data changes, you have to redevelop that package, save it, compile it, push it out to your test system, push it out to your prod system, and you're doing constant code deployments because of data change. That, for me, now is an anti-pattern because of tools such as Spark, because of the lake ecosystem. So there's just things that we can do better because of these tools. And whether it's Synapse Spark tools or whether it's Databricks, they can both give you that power and flexibility. That's why we've adopted it so heavily.